At first glance, a can seam looks like a simple rolled edge. In reality, a reliable closure is built through two carefully controlled forming operations. In the next few minutes, we'll look at how a can seamer creates the double seam, which machine elements matter, and what production teams should inspect. A can seamer does not weld the lid to the can body. It mechanically interlocks the body flange with the curl of a compatible can end. Inside the finished joint, the body hook and cover hook overlap, while sealing compound occupies design spaces. Correct metal formation remains essential. Compound cannot repair a fall seam. The key working elements are the end feed and placement system, the lifter or base plate, the seaming chuck, and the first and second operation rolls. Transfer, drive, guarding, and discharge systems keep the process synchronized. Every contact profile and change part must match the approved can and end specification. Similar diameter alone does not prove compatibility. The sequence begins when the can and end enter the seaming section. The end must be correctly oriented and undamaged. The lifter supports the can and brings the assembly against the chuck. Stable centering, controlled lift, and clean contact surfaces help prevent slipping, tilting, or circumferential variation before the rolls engage. During the first operation, a purpose-shaped roll progressively folds the end curl beneath the body flange. This creates the initial body hook, cover hook, and interlock, while distributing the metal for the finished seam. A poor first operation shape normally cannot be corrected by simply applying more pressure during the second operation. The second operation roll then compresses and finishes the layers already formed. It brings the hooks toward their specified geometry, manages wrinkle condition, and compresses the sealing compound within its intended area. The objective is not maximum force or the smallest possible seam. It is the approved finished condition for that exact container system. Quality teams may evaluate seam width, thickness, countersink, body hook, cover hook, overlap, wrinkle or tightness condition, compound distribution, and visible defects. These measurements must be judged together and against the approved container specification. There is no universal seam dimension or machine setting for every can. Leak or pressure testing can add evidence, but it does not automatically replace teardown or cross-section inspection. If a seam is out of specification, first contain the affected production, confirm the can, end, tooling, and applicable specification, measure the actual condition, inspect components and the seaming area, and review the first operation when authorized. Then check chuck and roll condition, lift, alignment, transfer, contamination, and head-to-head variation. Qualified personnel should change one authorized variable at a time and verify new samples before release. When selecting a can seamer, start with the application, not only a headline speed. Review controlled can and end drawings, product and fill conditions, normal and peak output, line interfaces, changeovers, inspection requirements, utilities, cleaning, safety, training, and acceptance testing. The best configuration is the one that repeatedly produces the approved seam. For a deeper look at rotary operation, quality parameters, common defects, troubleshooting, and machine selection, read the full technical guide at n.czwiki.com/howdoesacanseamer work. The direct link is in the description. Thank you for watching.